All right. Now, in terms of the logic of the nonparametric tests, the t-tests that we learned about in Chapter 7 and the f-ratios that we talked about in Chapter 8 and the techniques for correlation and regression that we finished up with Module 6, are all parametric tests, meaning that they have assumptions about the underlying nature of the data. So, for example, they assume that data are interval level. They assume that the dependent variable is normally distributed. All of these assumptions make them parametric tests, meaning that they have assumptions about the underlying parameters involved in the tests. But not all research questions meet these criteria, and this is especially the case for nominal data. And as we're learning about the nonparametric tests, we need to keep in mind that parametric tests are much better in terms of statistical power. Statistical power is the probability that we're going to correctly reject a null hypothesis. So if I conclude, for example, in a test of two means that the means are statistically significant, okay, that there is a significant difference between those means, that conclusion has a lot of power in that I'm likely to correctly reject that null hypothesis. But non-parametric tests are not as powerful as parametric ones. So what this means is that sometimes we'll fail to find a significant effect that might actually be there. And this is just because of the nature of non-parametric tests. So against that backdrop, let's learn about two non-parametric techniques.